go over simplifying expressions today. When we say simplify, we mean rewrite each expression as simply as possible. You're trying to reduce the number of symbols used and get rid of parentheses, reduce anything that looks like it ought to be reduced. In the first example, the simplifying required would be to combine any like terms. We have 16 and 5, and those can be added together, which is 21. I would change this to add -2 so that everything is addition. 3x plus -2x is just x. And we also have 7y with no other like terms, so we just include plus 7y. This is completely simplified because all like terms have been combined. In the second example, the square root of 49 can be simplified because 49 is a perfect square. The square root of 49 is 7, and that's more simplified. When the square root is pre-printed in a problem, then it is asking for the principal square root, which is just the positive solution. In the third example, we just have a fraction that ought to be reduced. Let's divide them both by 6. So 42 divided by 6, 36 divided by 6 is 7/6, and that is simplified. You can change it to a mixed number, but that isn't more simplified, it's just a different form. Lastly, we've got one with parentheses and some other things. If we try to follow the order of operations, we want to start in the parentheses, but this is one of those situations where you can't add what's in the parentheses, so we get around that by using the distributive method instead. I am going to change this to add -6. This is -6 times everything in the parentheses. So let's rewrite this. We still have 8, and then we multiply. -6 times the first term is -18x, plus -6 times the second term makes -24. Now we combine like terms if possible. We do have 2 like terms right there. So 8 minus 24 would be -16. Adding -18x is the same as subtract 18x, which is considered more simplified because there are fewer symbols used, and that's completely simplified. Here's some more. When we see a complicated looking fraction like this, there are implied parentheses in the top and bottom of every fraction. The numerator needs to be simplified first before you divide by 3. So we have -22 over 3. That's reduced completely, and so we stop there. Next, we have something that's even more complicated in the numerator, but let's pick it apart. First, we need to distribute because we cannot add together the terms that are inside the parentheses for either one of these, so we're going to distribute. So we get a -2x. -2 times -8 is +16, plus 6 times x minus 66. All of that still divided by 2, but we do need to finish simplifying the numerator as much as possible. I've got -2x combined with 6x is 4x, and 16 minus 66 is -50 all over 2. This can be reduced, but when you have more than one term in the numerator separated by addition or subtraction, you have to factor out a 2 in order to reduce. So we divide both uses of the numerator by 2 and rewrite it with the 2 out in front. So it turns into 2x minus 25 times 2 all over 2. And now that this is being multiplied, it's a factor, and so we can reduce by a factor of 2. And what's left is no longer a fraction, it is 2x minus 25. And that is completely simplified. Let's look at our last example. This is equal to -1 times -3 times itself. So we have to do the -3 squared first, and we get -1 times +9, which is -9, and that is the answer. Okay, here's one for you to think about. This is how adding and subtracting polynomials looks. You don't need the parentheses around this polynomial, they're just for organizational purposes. This one is a little different. When you see subtraction in front of a polynomial, it means add -1 times everything inside, which will change all the signs of these three terms. The last set has an addition sign in front of it, and so it doesn't require parentheses, and we'll be dropping those. So let's rewrite this. The second one, everything gets multiplied by -1. So we've got switching signs for everything. And finally, we just drop the parentheses on the last part. And now, if we change them all to addition, then we can use the commutative property to say we can do this in any order that's convenient for us. So that's why we can combine things that are out of order like this. 5x squared plus -12x squared is a -7x squared. If we combine all the x terms, we've got one here, and here, and here. That's 2 x's plus 8 x's, so we've got 10x. And finally, the constant terms, we have a -4, a -17, and a -9, -30. That is completely simplified. So that'll give you a good introduction to simplifying. You have lots of examples in your homework, so go try some.